Hi, I'm going to take you through some of the, well, basically all the work that we did in St Martin. We were there for 3 months and got quite a bit done when we were there. We're just going through a list of things. So for the high level, it basically was we changed the batteries from the old AGMs to lithium. We installed some new solar. We put in some new instruments. Put in a washing machine. We did a rigging check and changed the Genoa swivel because that seized up on the way up to St Martin. Alright, so we're going to have a look at the new instruments now. So we'll just head over there. So hopefully you can see this. It's a bit bright, but so what we got is so there's this new pod here. So this was all existing, but we just had a very narrow pod with just a couple of displays, a bit like this. So this is a new pod with a chart plotter on it. So this is sort of this word. So you call it a B&G Zeus 3S 12-inch, and it's all touchscreen. So you can see this is the maps where we are at the moment. So here we are on Bonaire. So you can zoom in and out either with touchscreen or just by using the buttons here. So this is where we are. So you can see we're pretty close into the shore, and you can see when we swung around the other day, we sort of, even though we're on a very short mooring line, we sort of swung in even further. But that's us. So in here you've got all the different information. This is all configurable, what you want to see here, but it gives you information about, you know, obviously heading, apparent and true wind angles, the depth, and then you've got the actual tide, state of the tide as well. And then so there's various different displays that we can use. I mean, there's a lot of things in here that we don't use. So echo sounding, side scan, down scan, radar we don't use. But the main ones is the chart, and then something called sail steer, which is actually pretty cool. So this gives you all the information you need when you're sailing. So on here, so it's giving you, obviously we're not moving, so we don't have it. The true and apparent is the same. So the green triangle here is showing you the true wind angle. The blue is the apparent. Obviously it will be different if we're moving. And then this is our heading, and then the magnetic heading. And then here, this is actually, if we were sailing, this shows you the effect of current or basically your leeway. And then here it gives you your tack angles. So again, if we were sailing, this shows you if you go from one tack to the other, exactly what heading you would be on. So it's pretty neat display actually. But the way we use it most of the time is in a sort of split screen like this. So you can have the chart information here, where you can zoom in and out and do whatever you like, and then over here we've got all the sail steer information. And then sort of coming back to the chart again. So on here we have all the AIS information. So you can see these are the black triangle, and the dotted line is the AIS signal. So we click on that. So we've got toes in the water, and gives you the standard AIS information here, the usual bearing distance, the closest point of approach, and how long it's going to take to get there. So yeah, and if you had B&G radios, you can actually call them directly from here, but we don't. So. And then other things, so like I say, we don't have any of these bits plugged in, but wind plot's quite a useful one. Again, particularly the other day, it was quite useful because this just plots the true wind direction and true wind speed over a period of time. So top of the screen here is now, and then this is sort of the history, sort of going down to sort of 30 minutes, but I've only just switched it on, so we've only got 5 minutes or so of history. So you can see here the dotted line gives you the average, so the average was gone, basically went down and then came up again. So we currently got 12 knots. And then here gives you the indication of what the wind direction is and how that's changed. So that's quite useful sometimes. And then we have instruments as well. So in here there's a number of different dashboards, but the bits of kit which got posted to London and then by mistake, and then you forward them on to here. They were the interfaces onto the Volvo MDI, sort of electronic sort of control box. If the engines were running, we would be able to see the RPMs here. So you see the RPM information, and you also see the engine hours, and also the the engine temperature as well, which is good because at the moment we don't have any temperature dials anywhere. We just have an alarm, so that's quite handy. So that's that. And then so there's all sorts of other bits and pieces on here, most of which I'm not sure I've actually quite worked out yet. So there's a lot of features on here. But if we go back to the chart, you can see our track. So we just zoom out. So actually, hold on a minute. Where's our track gone? Okay, and then we're outside, and if you remember, we used to have two of the old Pruno displays here. So we've just gone with a single one on each side of the cockpit. So again, it shows it's the same as the display inside, so we can change it to to whatever we want. But yeah, it just means that you don't have to, again, if you're sitting outside but don't want to be at the helm, you can read the information from here as well. So yeah, that's pretty useful. And then there's one on both sides as before. Okay, so we'll have a look at the lithium battery installed now. There's not that much to see, to be honest, but so in here, so those are the new batteries. So there's 16 individual cells, and then so each one of these 4 in parallel is a 3.5 volt 720 ampere hour battery, and then we connect 4 in series to make a 12 volt. So we got 720 ampere hours, 12 volts, well 13 and a bit volts of lithium, and that we had 700 ampere hours of AGM before, but with the AGMs you can only really discharge them about 50%. With lithium you can take them down probably to somewhere 10%, no problem. So that's effectively doubled our capacity. But then one thing with the lithiums is that you do need to have what's known as a BMS, or battery management system. So that's what this is. It's called the REC BMS, and this box is the brains basically. And then, so as you'll see, there's wires going to each of the 3 volt batteries. So what it's doing is measuring the voltage on each of these batteries, because one thing with lithium is that it's very important that you don't overcharge them or to over discharge them as well. So what this does is ensures that you never get to that point. So what it has, I'll show you in a second, there's a couple of contactors over there that will actually just disconnect the batteries if they're being overcharged or over discharged. And the other thing this system does is it actually balances the batteries, such that if you get a slight imbalance, so one of these 4 cells connected in parallel, if that then starts to get a higher state of charge relative to the other ones, then it starts to bounce them out again. Because one thing with lithium is that the voltage spikes when they're charging. The voltage spikes very quickly when they're becoming full, so it's possible that one battery can sort of run away ahead of the others. At that point, then the system will actually stop the charging at that point. Yep. So that's the BMS, and then over here. Well, actually, this is the screen. That's the screen for the BMS there. So you can see we're at 94% state of charge. Battery voltage is 13.5 volts, and then here you see at the moment we're currently drawing just 3 amps out. That's the net. So that's the solar. Well, the solar is in float now anyway, but this is the net in and out that's going into the batteries. And then you see here we have this is the maximum of those 4 cells. The highest is 3.372 and the lowest is 3.354, so within a few hundredths of a volt of each. And then you've got temperature, and then the time till empty, and that's just the power that's currently being drawn out. So this gives you the display, basically what's going on. And then over here we have a new Victron battery monitor, and this is actually looking at the cells in total. So in here what we're seeing is the total battery bank voltage, and then what's important here is that this voltage is used by the solar panels to determine whether they should be charging at full whack or whether they should be going into float. And this is Bluetooth connected, so each of the solar panels has its own solar charge controller, which is also Bluetooth, and they're all connected together to make sure that they're all working and charging in sync. And then down behind here, I'll get this out of the way. So you see in here, these are the big contactors here. So you see that's the discharge cutoff, and that's the charge cutoff down there. So these are controlled by the direct BMS that we were looking at. So if at a point at which, say, we've left something on which is taking too much power out of the batteries, if we don't notice it, and there's various alarms that go off, but if it gets to a certain cutoff, then this will trip and actually just disconnect the batteries. So disconnect the inverter from the batteries, so that basically no further power can be taken out until you come back here and manually reconnect it. And the same is true of the charge cutoff down there. So that, there's other safeties in here as well, but if one of those didn't work for some reason, the ultimate safety is that, again, if we get to one of the cells goes over, I think it's 3.7 volts, then that will cut off and that'll just disconnect all the charging sources, so we don't damage the batteries. So the install's a little bit tricky, but once it's up and running, it's as long as everything works properly, it should be all good. And then, so what's been great about that is basically what we can do with the extra power that we've got now. So we basically, as I said, we've got double the capacity that we had previously. So that means now that we can run the washing machine, which I'll look at a bit later, and then directly off the batteries. And then we can also run things off the batteries that we never had the capability to do previously. So in the past, whenever we wanted to run the water maker, because it's a 220 volt water maker, we had to start the generator. And the same is true of any of the water heaters as well. But now all that's been rewired, that it can be run off the generator if it's running, or if not, it will run just directly off the batteries. So it gives us a lot more independence, and it means on a normal sunny day we can make water for a couple of hours, because it does still take quite a whack out of the batteries. But then, as long as we finish by early afternoon, then by the evening the batteries will be back up to 100% again, charged up by the solar. Has also meant that we've been able to buy an induction cooker as well. So obviously gas is a bit of a problem if you run out of it, and so what we bought is this little induction cooker, which I'm not sure where it is now, but it's just a little portable one that we can just put on top of here, and it's quite powerful. It's like 2,000 watts, I think. So actually the limiting factor for us now is really our inverter, which is 3,000 watts. So we're thinking about possibly getting a larger one, but we'll have to see. And then, so the other thing we can look at is the washing machine. We come down here. So on this boat there is a dedicated hot cupboard for it, which up until now has just been a sort of a place where we've dumped everything. But you can see sort of the washing machine. It's quite a small one, so 4 kilograms, but it fits in perfectly. I think it's actually one of these smaller ones that are designed for boats and RVs. So it fits in nicely on this little shelf that we had to put in here, and all plumbed it in. So yeah, it's all working well at the moment. So these lines here, so these are the reefing lines. It's like a traffic light system. So green is first reef, yellow second reef, red third reef, and same over here. Because these are the mast end of the sail, and these are the clew end of the sail. So these are all the original ones. They're all now becoming a little bit old. They don't look too bad here, but where they go over the pulleys and things, they've been actually wearing and chafing a bit. So as we're going sort of some places in the future that would be a bit more remote, we thought we'd take the opportunity to change them now. Main halyard was replaced, well, a couple of years ago now when we bought the boat. That's a new line as well for the topping lift, so that's okay. Yeah, but we changed here all the main sheets, so these are new lines, And this obviously is the new solar panels. You can see here, so they're tilted back, because obviously the sun is, we're now sort of late afternoon, sort of 4:30, something like that. So they're tilted back against the sun, and it means that they can actually produce a lot more power when they tilt like that. And then after it goes dark, we sort of tilt them back, back the other way, such they're ready first thing in the morning when the sun comes up to start picking it up. And then I'll show you later on actually how all the adjustment works. And then, so coming around here, so this is all pretty much same as before. Got our pedal boards pumped up. So the new Genoa swivel, well, you can't really see that, but up there, that's not to let you know that we have to replace that swivel, just because the old one locked solid. So luckily we were able to put the sail away when that happened, but it could have been that it could have got stuck out. So and then these are the new bow plates down here. So you see these stainless steel plates that are put on here. So we've had a problem, as you can see here, when we're attached to on a fairly short line as we are here to the mooring buoy, the lines come down over the edge of the deck here, just here, and it was actually cracking along here. It was actually cracking the gel coat because of the pressure of the lines. So we got this bow plate put in on this side and the other side, and that's now obviously distributes the load across there, so that doesn't happen anymore. So I think they look pretty good as well. So, well, they should do for the price that it cost us anyway. I think that's pretty much everything for up here, I think, apart from the windlass, which we serviced. Here's again the bow plate on this side. So you can see here, took a bit of a, even here, this is, you can see how the rope is actually marked even onto the stainless here with the pressure of the storm the other day. Anyway, and there's our lump of concrete, or two lumps of concrete down there that kept us in place during that storm. I mean, they're a couple of tons each, probably even a bit more maybe, but we certainly moved one of them a little bit, because it was we went down and snorkeled on it this morning just to make sure everything was okay. But it held well enough anyway. And then in here for the windlass, so this was we had to replace the clutch cones and the gypsy. So this is all, the rest of it needs a bit of a polish, but so the clutch cones in here and the gypsy are all new. So because these teeth had worn away and the chain was starting to jump a little bit, but it's working well now. It's all probably greased up, so we can do a free drop, which is without using the motor to drop the chain if we need to. And we changed the oil in there, which was just as well. It turns out there was an oil leak we would never have known. So yeah, we fixed that, and luckily had the seals for that, and so it's all up and running again, which is good. We can go and have a look. Well, not there's that much to see with the engines and the generator in the engine room, and not we can see much. But so this is a new exhaust elbow, so we changed this to a stainless steel one because they have a limited life. That was basically rusting away. Like we said, changed the coolant, did various other bits and pieces, so nothing much to see as such. One thing we did do, you can see down here, so this is the water intake from the sail drive. So it comes out of the sail drive here, and normally, and then up here through the strainer into the heat exchanger. But what we've done is put this T on it here, so that if we move this round, what happens actually, it pulls the water from a pipe which is over here. So what it means is that we can flush the engine through with fresh water, and it also means that, as we had this problem actually when we were in SVG last year, that bugs and crustaceans and all sorts of things go up inside the sail drive and they can block it up. So it means that if we absolutely have to, then we could actually, and we'd have to get a bit of a hose extension and sling it over the side, but we could draw water from any other source, which is good. It also gives us the ability, like I said, to run fresh water through it if we're not going to use it for a while, so that stops the electrolysis. And then we can even, every 6 months or so, apparently it's quite good to flush the engine with fresh water and vinegar mixture, because that'll then clean out the deposits from the heat exchanger, because that's quite a problem. And actually, it's one thing I forgot to mention. When we were in FKG and this was being done, there was such corrosion around here that basically we had to, with FKG, had to weld on or build up the metal again. Had to grind away all the rust, the corroded metal, and then put on basically weld it up again and make it flush. Because either that, or we're going to have to buy a whole new heat exchanger, which would have been thousands. So luckily managed to get that fixed. We were there. So just as well we did, because it was actually on the other side, it was starting to leak. I hadn't really noticed it, but it was leaking down, and actually I think it was from the other end here, it was leaking down. It was hitting the starter motor, actually, I think. Anyway, all right, so I think that's it for in here, apart from the autopilot ram here beside me. So we serviced this, changed the hydraulic fluid and that, so that's all ready to go. Alright, so this is the new solar panels. So you see here we've got three, actually let me move it over so you can see it easier. So here you see we've got three new panels, each 445 watts. A bit dirty at the moment, but yeah, they're great actually. It's amazingly efficient on overcast days. We're actually producing enough electricity for all our needs during the day and actually to charge things up. So that's great. And then so we've got these two lines attached. So they go through a jammer here, and each one there's a number of blocks, little Harkin blocks that they go through around to the other side. And there's one line that goes around the front, and one line that goes around the back. That means you can adjust by pulling in one line, letting out the other. You can adjust the angle to it back to where it was, and then you just close the jammers here, and it's locked firmly in place. So that the previous video that was filmed at about 9 o'clock this morning when it was overcast, and it's still overcast outside now. But if you can see, so now we're actually charging like 24 amps. It was up at 30 a moment ago, even though it's fully overcast. So yeah, the solar really is working well.